All right. Well, third time's a charm, maybe. I hope. All right. So for this one, we're going to be discussing the what are called a proportions test. It is very similar to back in chapter 7 of the book. If you took 243 with us, if you didn't take 243 with us, you took it somewhere and you did a confidence interval for the unknown proportion. Well, here what we're going to say is this. Under H naught, we're going to say that the proportion is equal to something, whatever it is. And of course, or it could be greater than or equal to or less than or equal to. And of course, the alternative to that is, well, it's not. Okay? That's great. We can do two tests and two tails and one tail and all that good stuff. The question then is, well, wait a minute. How is p hat? How is it distributed? Well, it turns out it's distributed normally, big surprise, with the same mean as the actual population. Okay? But the standard deviation is given by PQ over N. Now, that's a big deal. Notice it's P and Q, not P hat and Q hat, P and Q. Because remember, we are assuming. Be careful when you make assumptions, yes, but we are assuming that P is true. We're assuming that P that's under P naught, or under H naught here, this P, which we refer to as P naught, of course, in the calculator, right? Because under the null hypothesis, we're assuming that this guy is true. And so we're going to work forward under that assumption, and so that affects this piece right here. Well, that's interesting. That means I can make a z-score if it's a normal distribution. You're right. So it becomes this guy right here. Or just P if that makes you happy. I'm just going to write P. I'm not sure why I stuck P naught. That doesn't affect anything, but I could have done it that way. Go away. Alright. Over, and it's just the square root of P, Q, over N. Nice. And we're going to make a z-score from that. Well, if it's just a z-score, then it's literally just a matter of putting our alphas over here on the sides and all that. It's exactly like that. Well, this isn't going to be very hard. I mean, it's not going to be hard at all, not even a little bit. Okay? So, what percent, or no, I'm saying what percent. I shouldn't say it like that. Let me start off with this. Again, we need to make some sort of assumption. We need to make some sort of a statement. So, I don't know, Daphne. How do you spell Daphne? I don't know. One of those two ways. Believes that the percentage of students who commute to Portland State is greater than 40%. Boom, statement. Mic drop it. That's what I heard. I heard this. I heard Daphne say this, and I heard her say this. I heard her say that. So, of course, the opposite of that would be this deal. The upper tail test. Don't know what alpha yet because they haven't got around to telling me yet, but it's over here somewhere. So, what does she do? Well, of course, she takes a sample. That's what we always do. Oh, I don't know, 300 students. Well, good for her. And finds 146 commute. So at alpha equal 0.05, is she right? I don't know. So we're putting 0.05 over here. We do an inverse normal on that. It turns out this is 1.645. 1.65-ish. You know, when I was a kid, we always rounded it to 1.645. Some books would have you do 1.644. Some people do 1.645. Whatever, 1.65. Not a big deal to me. Which route you go? It's in that ballpark. Okay, so we're going to make our z-score. So our z-score is p hat. Well, we don't know p hat yet. We kind of do, but we kind of don't. Open up. Have a kid. Open. Home. 6 divided by 300. 48.6%. 0.486 minus 0.4. Again, it's bigger than that. Otherwise, I don't think Daphne would have been like, oh, I know, let's go test it. I think she had a pretty good inkling that it was greater than. The question was simply, is it not just has it increased, but has it increased, significantly? That's really the question we're studying here. Okay. Now, again, you can round this a skosh one way or the other. That to me isn't the hugest deal. I know some people make bigger deals about that than others. Being as how this is my class from start to finish this time, I'm not going to be maybe as picky as last term when I was teaching someone who's already had it kind of set up for me, which was fine. But just be aware that rounding it's a big deal, but it's also not that tricky either. So it's right at 3. That's a z-score. Listen, friends, if you get a z-score of about 3, what are you going to do? You're rejecting every time. But anyway, again, here it is. We're out here. So what are we doing? Rejecting h0. And what does that mean? Well, that's what Daphne said it was greater than. So Daphne seemingly is correct then. Reject h0. Well, Daphne is right. It is significantly higher. Significantly higher. Boom. It's great. There's really nothing to this problem that's any different than any other z-score. So in terms of finding the inverse normal and all that is exactly the same, whether you use Excel or any of the other products. That part is all the same. The one thing that's kind of cool about the calculator, of course, is there is a test button. So it's F6, again, under here. We will also make a video for this with the 8384s. So watch the follow-up to that. Under the null hypothesis, it's 0.4. We had how many successes? We had 146 out of 300. And we said this was an upper-tailed test. So this guy, 3.06. Nice. And a p-value of 0.001. Again, the p-value is all I really need. If I was doing with the calculator, that's all I would do. I'd just go boom, 0.001. Hey, that's less than 0.05. Hey, I'm done right now. Who haven't we done from the... Oh, Shaggy. Shaggy believes the proportion of broken Scooby Snacks is different than it used to be. Ooh, no, wait a minute. Different than they claim. Than the manufacturers claim of 5% broken pieces. Yes. Nice. So what does he do? Well, he samples 1,000 pieces and finds, I don't know, 65 broken pieces. Yes. Alpha is 0.05. Is Shaggy correct? By the way, notice he said it was different. And by saying it's different, it's a dead giveaway. We're talking about a two-tailed test. So it's two tails. That's negative 1.96, positive 1.96. Use your inverse normal of 0.025 to get that. So what I heard Shaggy say is he is, oops, it's not P. I mean, it's not mu. Be careful. Sometimes it's easy to do when you're thinking about something else to write mu. It needs to be P because this is a proportion that we're talking about. Proportion is 5%. That's what the company claims. Shaggy, after handing these little Scooby snacks out to Scooby, realizes he thinks it's different. It's changed. It's not the same. He thinks they're wrong. They're lying. They're trying to get away with something. Big corporations. I don't know. However you want to say it. Okay? So 0.05. Oops. Getting ahead of myself. I think about other things when I'm writing than when I'm thinking about. All right, let's try this again. So our P hat, rather, is, as you might guess, is 6.5%. But let's go ahead and divide it out. 65 divided by 1,000. 6.5%. Minus P. .05 times 0.95. Now remember Q hat, what our Q is what? It's the probability of not, because this is a binomial situation here. In other words, the idea is you did or you didn't. Either it is broken or it's not broken. You're pregnant or you're not pregnant. It's raining or it's not raining. P is success, Q is failure. Okay, again, if that's been a while, you may want to ask some questions about that. Whether you do more reading about it or you can send me an email and we'll get you caught up if we need to. So I'm going to go ahead and do this one out old school this way, then I'll show you also how to do it if I was doing it with the test button. Holy buckets. Oh. Anybody notice something there? Apparently I missed a 0. There we go. Oh, 2.17. Okay, that's significant, but not as significant as the other one. Are you with me? 2.17. Well, that's out into here somewhere. So again, we're rejecting H0, and what does that mean? Shaggy's correct. So reject H0. All right. The proportion of broken pieces has changed significantly. Has changed. Remember, it has changed because that's what they asked about. They didn't ask about increasing or decreasing, so make sure we get that right. C right there somewhere. There we go. That's right. Now, what would the p-value for that be? Okay, well, glad you asked. So I'm going to go into this, and I'm going to see what's up, and I'm going to do it two ways, just for fun. Now remember, F5 for distribution. I want a normal CDF. And I want to go from 2.17 to 1E99. And 0, 1 is right. And I will find that I get some teensy. Give it to me. I hit enter. Give it to me. Darn you. There we go. And so I get a p-value, or I get a value of 0.015. Now pay attention to that, because in a minute here, I'm going to do it with the test. And that's not going to be the answer that I get. So, and then we're going to talk about y again. So one proportion z-test. And so under the null hypothesis, it was 0.05. And we got, what did we get, 65 out of 1,000. And we said it was not equals to. And we get a p-value of 0.0295. Interesting. That's like, why, that's almost twice as big as we had. It's literally twice as big as we had. Now the reason for that again is because that p-value is, the p-value on a two-tailed test is from here out plus from negative 2.17 out. And so together it comes up to 0.0295. Okay? But again, that's how you find p-value. So if I was doing it in Excel, I would do equals norm.s.dist, this guy right here. And I would do 2.17, comma 1. And that would give me less than, well, I want an upper, originally this was on the upper tail, so I do 1 minus that. And then I would say it equals 2 times that guy. And so basically get a p-value of 0.03. Okay, and that's the game. That's how those work. That's where the p-value comes from. So when you're doing these tests and the thing spits out, hey, the p-value is this and such, well, that's it. Now notice that our z-score wasn't exactly 2.17. I rounded it to 2.17. Had we left it at 2.16, yada, 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 we'd have got the exact same p-value as they did. Okay? Now, you know, so you could say things like, it used to be, oh yeah, so Art believes the percent of ketchup sales going to Heinz brand has decreased from where it used to have 40% of the market share. Okay? I don't know. Why would Art believe this? Art works at the grocery store and Heinz doesn't sound like it used to. And if it's not sounding like it used to, then give them a smaller spot on the shelf and get more of the whatever brand, Winco brand or whatever you have in there. By the way, why might it be selling differently? Well, John Kerry's involved with it, so maybe it has something to do with him personally. Maybe, maybe not. Maybe people are saying, you know, their ketchup is expensive and the Winco brand tastes just as good. By the way, if Art worked at Winco, my guess is that Art would be thinking about what's going on at Winco. But if Art worked at what, Whole Foods or someplace, then there's some organic ketchups that are taking over. People aren't eating the Heinz ketchup because it's not organic or whatever, right? Again, it matters what population you're talking about. It always matters what population we're talking about, okay? So, you know, in reality, keep in mind that you can't tell you the whole freaking story about where Art lives and works. Is it the Winco in Cleveland or is it the Winco in Salem? God, we don't know. But you know, obviously it's about where his thing is. It's not like he's not making a statement. He lives in Oregon. He's making a statement about what kind of ketchup gets sold in Houston or something, okay, at a Whole Foods. So clearly he has a reason to think this is true. And so, you know, we can hear it already. We're going to go ahead and write this out because that's when I felt like doing it, is right now. It's where it screams it to me. So it's less than 40 and it's greater than or equal to 40%. I don't know. Let's test this at alpha is 0.1 for a good time. So what does he do? I don't know. So like he samples. Now this is, of course, that's, you need it, you know, ketchup sales. Well, I'm guessing that's per day. Okay. So, you know, from the last, you know, let's just say the last, we'll just do the last 200 ketchup sales. So this is 200 ketchup sales. And they sold 70 bottles of Heinz. Okay, and so that makes that p hat would be 35%, I think. Okay, and so let's test that. So again, if you're making this at home, the z-score is going to be 35% minus 40, which would give us a negative, which is good because we were talking about less than. And then divide out by the square root of, again, under the null hypothesis, it's 60-40. 40-60, whichever way you want to write it, not important. over 200. Yeah, please keep in mind as we're doing these, there's lots of things. The book always kind of gives you the short story. By the way, sometimes you won't think it's the short story. You're like, holy cow, there's a lot of background information on this. But there really has to be, in order to do it correctly. There's a lot of reasons why things get done the way they get done. Okay, so negative 1.44. Interesting. Ah. So I think my other pen, I can just push a button. I don't have to come up here and do all this routine. Negative 1.44. Interesting. So if a person were to make a cutoff score for this thing, and so we know we're testing this at 0.1, well, we come in here and go to apps and flash apps, and then stats list editor is what we're looking for. And then F5 is an inverse normal 0.1, and you'll see it's negative 1.28. Negative 1.28. So where are we at? We are out here. By the way, if I had asked about 0.05, I would have failed to reject. Because had I asked about 0.05, I think I did 0.1, didn't I? Yes, indeed. But if I'd have done 0.05 instead, I would have gotten a critical value of negative 1.64. And that would have been in here, and I would have failed to reject. See that? And so, because we're doing this, of course, we're going to reject H naught. Reject H naught. What is that going to say about my p-value? My p-value is going to be less than 0.01. I guarantee it. Guarantee it. You know, that's not a Joe Namath style guarantee in that, you know, it could go either way. No, it's fact. It's fact, man. So 0.4, and we got, what do we get here? We got 70 out of 200, and we did a lower tail test. Give it to me. And we got a p-value of 0.074. Nice. But again, by the way, had I done it with 0.05, 0.07 is bigger than 0.05, I would have failed to reject, and because it's in here. But down here, 1.44 is out here, well, my p-value is less than alpha, so I reject. Okay, but reject H naught, and what does that say? Art is correct. Yes, Heinz sales has decreased in their market share. Okay, and again, we're statisticians, we're not politicians, we're not this, we're not that, we're not whatever. All we asked were, can we say it has decreased significantly? Yes, it has. It has decreased significantly. It is now significantly less than 40% of the market share. Okay, let's do another one here. One more, and then we'll, I think, call it good on this guy. Okay, so again, you need some sort of thing. So Susie, yes, Susie says 50% of all women dye their hair. That's a bold statement. I bring that up because the other day in one of my classes at the high school, there was 14 girls in the classroom, and this one girl said something about dyeing her hair. I'm like, I thought that was your normal color. She's like, no. And then I was looking around the room, and I'm like, well, I looked at this one girl. I'm like, well, that's your normal color. She said, no. And there's only one girl in the classroom with her normal hair color, and I would have bet you $1 million that was dyed. It was crazy. It's like full out 13 out of 14 of them. Now, when I say all women, apparently I mean all women, including my grandma, who I didn't know dyed her hair until she got sick and couldn't dye it anymore, and she went gray overnight. And I said to Mom, I'm like, is that the sickness that's causing her hair to go gray? She's like, are you kidding? She's been gray since she was 25. And I'm like, what? She's like, oh, yeah, she's dyed her hair for years. Didn't you know that? I'm like, Well, no, because that grandma always had her hair black, whereas my other grandma always had it kind of a purple color. So that's pretty obvious. It is this purpley gray look. But yeah, it's weird. So this is what Susie says. What is Susie saying this? Because she's a beautician? I don't know. But Susie apparently cares or says something about this. So what does she do? She takes a sample. So she takes a sample of I don't know, 150 women. Sure. And finds 72 of them dye their hair. God dang it. I almost did it earlier, and I'm like, no, come on, you know how to spell it, Jay. Don't mess it up. My Alzheimer's kicking in. Dye their hair. There we go. And let's do a little alpha 0.05, shall we? Just for a good time. So what did Susie say? Well, Susie said that the P was 0.05, or not 0.05, just 0.5. There you go, 0.5. And of course, the alternative to that is, well, it's not 0.5. I don't know what it is, but it's not 0.5. That's the alternative. And so Z, you see, equals, well, 72 out of 150, that would be our P hat. Don't really know what that is, so let's go ask Betsy. 0.72 divided by 150 is... Oh, and I put 0.72. Let's try that again, Jay. Well, what do you know about that? It's 48%. Anyway, 48% minus 50%, because that's what it is under the null hypothesis, square root of 50 times 50 over n. And so when you subtract on top, of course, you're going to get negative 0.02 divided by the square root of, that's 0.25 divided by 150, right? And you will get negative 0.489 for a z-score. Geez, I'm shocked. I am just shocked. I'm not shocked. I made the problem up. Okay? Now, as you know, the critical values are somewhere-ish, but around-ish 2 z-scores. All right? Now, 0.05 is specifically 1.96 and negative 1.96. But again, 2-ish. This is in the middle. It's in here, for God's sakes. It's like in here somewhere. So what am I going to say? Well, I'm going to reject H naught. I fail to reject H naught. And what does that mean? Well, that means Susie's right. Susie is right about percentage of women who dye hair. Yeah, that's the gist of it. Okay? I can't prove her wrong based on the sample that we took. Based on the sample that we took, it seems to agree with her statement. That's what we're saying. Now again, you can use the calculator for this. Okay? And, alright, so F6. You'll notice that what it doesn't give us a chance to do here, it doesn't allow us to give data. Because what would you type in? Yes or no? Okay? Yeah, it wouldn't be impossible to do it that way. So what do we have here? We're saying that there was, what did I say, 72? Oopsie daisy. Oh, no, it's not true. We're saying 0.5 there. 72 goes here, right? And out of, again, 150. And it was a two-tailed test. So right here. And we see we get a p-value of 0.62. In other words, there's a 62% chance that happened if H naught is true. 62%, holy cow, I'd be happy with 10% or 20%. But 62%? Of course. That's why we're failing to reject H0. Again, follow-up video quickly for how to do this with the 8384. It is very similar. Well, it's not similar. It's exactly the same. The only difference is how you get to where that test is. So it'll be like literally a 2-minute video follow-up to this one.